Am I on? All right. All right. Well, hello everybody. Thank you very much for coming. Great to see so many people here. My name is Scott Kuykendall. I am the Water Resources Specialist for the McHenry County Department of Planning and Development. I help oversee our county's scientific research into water resources, and we've done quite a bit of to understand our water. I help develop public policy to protect our water. I maintain the county's environmental compliance, and then I do a lot of public education and outreach like this. And to be honest, this is my favorite part of the job. I get paid to learn and then relay information back to the public. We're going to be talking about water resources. And like I said, I'm thrilled to see so many people here. Water is just an absolutely important topic. It's a topic that very few people really understand. Most people don't know where our water comes from, the threats to our water, and the opportunities to protect our water. So this really is important for all of us to understand and be on the same page. And so I'm honored to have an opportunity to share the information that we've developed over the years. And I have tried to tailor it as best as I could to DeKalb County and your particular region. There we go. So we're going to start out talking about water resources in general. We'll then talk about water resources for northeastern Illinois and DeKalb County. We'll talk about water resource protection efforts that we've done in McHenry County and some of the efforts that are being done by our neighbors. I have a time for about 45 minutes, and I'm going to talk very quickly. I'm triple booked today. I just came from a presentation, and I've got an hour to get an hour and a half drive after this. So I'll try and stay on track. I won't have much time for Q&A, depending on how much time we've got, but I will make my email and phone number available to everybody, so if you do have questions, I'm happy to speak with you afterwards. So we live on a blue planet where about 75% of the Earth's surface is covered with water, but of course most of that water is salt water. Only about 2.5 of all water in the atmosphere, on the planet, or in the planet is actually fresh water. And most of that fresh water is currently locked up in ice caps or glaciers. And of course, when that melts, that ends up in our oceans where it becomes salt water. Less than 0.5% of all, and I guess the remaining 30% is either inaccessible in a form that we really can't use. So only about 0.5% of the 2.5% is actually available for our use. And of course, we have to share that 0.5% of fresh water with a lot of other species and a lot of other people. When my parents were born, there were 2.4 billion people on the planet. Within their single lifetime, we've gone from 2.4 billion people to over 8 billion people, all needing to share finite resources on this planet, including that 0.5% of water. And unfortunately, our actions are adversely impacting that 0.5% of water. We are not treating this scarce resource very well. And water is necessary for every living thing on the planet, whether you're in the tundra, the tropics, or the Midwest. Every living thing on the planet needs water. When we're looking for life in the universe, the number one thing we're looking for is evidence of water. It's that critical to life. Because it's critical to life, it is also our number one economic driver. People are not going to invest in homes or businesses if we don't have access to safe, clean, reliable, and affordable water. So our water is our number one economic driver. And we're very fortunate to have renewable resources in this area. And that 0.5% of water is actually a large volume of water, but it's not evenly distributed across the state, the country, or the planet. In 2018, about 3.6 billion people lived in water scarcity. That means at some point in the year, they have no idea if they're going to have access to water. By 2050, almost 2/3 of the world's population will live in water scarcity. So this is a very real issue. And once again, in our area, we do have access to safe, sustainable supplies, but we're subject to the same laws of mechanics and IT as the rest of the planet, the rest of the world. So everybody that is running into scarcity or water problems, we're subject to the same laws of mechanics. If we don't take care of what we have, that will no longer be available for us to use. So, thank you. That was not as difficult as I was worried it was going to be. So, this is a map showing the distribution of water supplies in the state. So of course in the northeast corner, that is Lake Michigan water. The Lake Michigan watershed is actually just a very narrow band along the lakeshore in Illinois. Throughout most of the rest of the Great Lakes states, they have these massive watersheds contributing water to the Great Lakes. In Illinois, it's just this narrow band. The only reason water has been able to extend inward is because of a Supreme Court decision from the 1920s. We're not subject to the same limitations of the Great Lakes Compact as the rest of the nation, and they have a lot of resentment towards us because of that. That light blue area is just limited to the northeast corner. All the brown is groundwater. So in our area, we're 100% reliant on groundwater. Downstate, all these light blue areas are reservoirs. They don't have access to the same groundwater aquifers that we have. So they are forced to create reservoirs where they dam up a stream or river. That's very expensive water. It requires enormous land area. Very difficult to treat that water to drinking water standards, and a good percentage of that is evaporating. Ours is actually stored underground where it's not going to evaporate. You can't come up with a better storage device than what we have naturally in our area. So this is looking at the different aquifers that we have access to. So in our area, we do have access to 3 different types of aquifers. So sand and gravel, limestone, and sandstone. And I'll talk a little bit about each of these. So this is a cross-sectional view of the geology in northeastern Illinois. So when I'm working with students, I'll say, if you were a superhero and had X-ray vision and could look to the earth, this is kind of what you would see. And we're up in this area. Of course, in DeKalb, we're over here. This is sand and gravel that was deposited during the Wisconsin Ice Age, and this is where most of McHenry County gets our water. That geology is 20 to 12,000 years old. In DeKalb County, your geology was formed during the Illinois Ice Age, so your geology is about 100,000 years old. You don't have quite the same amount of sand and gravel that we do in Henry County, but your sand and gravel is an important resource. Below that is a layer of limestone, and you do have some limestone in DeKalb County. Both of these are really important because they are recharged locally. So when it rains or snow melts, water percolates down to the sand and gravel, moving down between the pore spaces between the sand and gravel particles, and it'll keep going down until it reaches a layer of clay or rock. And then it'll fill those pore spaces and create a water table. That water table will fluctuate throughout the year depending on how much rain we're getting and how much water we're pulling out. That's where we drill our wells below and get water from the sand and gravel aquifer. Below that is the limestone, and that's a hard, rigid rock, so it's not porous like the sand and gravel, but it can have lots of cracks and fissures. And where those cracks and fissures are aligned just right, it can hold and transmit a lot of water. So those are 2 very important aquifers that are recharged locally. Below that are 3 different layers of sandstone, and these are ancient geologic formations that formed when North America was actually close to the equator. The uppermost one is the St. Peter, and you guys have more access to that than we do. I'll show you another illustration of that. In our region, most of our water is coming from this deeper Ironton-Galesville. So you guys do get some recharge to the St. Peter. We're not able to use it where we are. It's largely been desaturated, and it's a soft, friable rock, so it breaks apart very, very easily and will destroy the pumps of the wells. So it's not used as an aquifer through most of our region. But you guys do get some recharge there and are using that aquifer. But the Ironton-Galesville is the main aquifer that we use throughout the region, and that actually gets largely recharged up in Wisconsin, and so it's not recharged locally. So in northeastern Illinois, we have communities composed of charming towns, productive farms, parks, and we have fun festivities. We also have natural areas, including prairie, savanna, woodlands, and wetlands. And then we have the 3 different types of aquifers, sand and gravel. This is from a gravel pit in Woodstock area. This is a limestone dolomite layer in Rockford, and this is a layer of sandstone that's exposed in southern Illinois. So just to give you an idea of the 3 different types of material we get our water from. And then we have surface waters, lakes, rivers, streams, and wetlands. All of these are interconnected. how we manage the land has a direct impact on each of these water resources, and the presence of these water resources is what enables us to live here. So all of these are interconnected. You can't really think of one without having an impact on the other. It really is important to understand. So this is an animated slide that an engineer named Jim Patchett put together about 20 years ago, and I've spent 20 years trying to find a better animation, and I have not found it. So when it rains or snow melts, before we started developing our landscape, most of that water actually infiltrated into the ground. And it would recharge the water tables, but water is not just standing still. Water is in constant motion, so it's moving downward, but it's also moving laterally. And it's providing a base flow of cool, clean water to our lakes, rivers, streams, and wetlands. So that's natural hydrology before we started packing the soil, paving over the landscape. As we started using more and more chemicals, soluble chemicals that we put into the air, onto the land, or into the ground, can also then come in contact with that water and be carried down. And that can contaminate our groundwater, and it has. So we've got many parts of McHenry County, some of the most productive aquifers in the world, that are not available to us because we've contaminated them. I'll talk more about that later. And then when we pave over everything, that water is no longer able to hit the ground. So when it rains, the water hits the ground surface, rushes off over the landscape, carries with it any pollutants it comes in contact with, and then creates a flood stage followed by drought. Flood, drought, flood, drought. So it's a completely altered hydrology. We're actually having to go back now trying to figure out how to restore that natural hydrology to mitigate flooding. We're actually getting more precipitation over the past 100 years, but we're getting into fewer and fewer storm events. Our built environment is not built for the amount of precipitation we're getting today, let alone tomorrow. So how are we going to build more resiliency into our built environment? This really is an important issue that we are investing in right now. So our water resources are vulnerable to a wide variety of threats. So overconsumption. If we're pulling water out faster than it's naturally being recharged, the water tables drop. Basic mechanics. Pollution. The pollutants we put in the air, onto the land, or into the ground can become a source of contamination. If that contamination gets in our groundwater, that groundwater is no longer available to us. So pollution prevention is actually a form of water conservation. And like I said, we've lost huge areas. Marengo fought for years to get an interchange onto I-90, and they were going to drill a new well to drive that economic development, only to find that it had been contaminated by one industry that negligently buried hazardous materials. So that is affecting their ability to build out years later. Recharge losses. We pave over the land. You can kind of think of our aquifers as a bank account. We're pulling more and more water out, but we're contributing less and less to it. And that is kind of an irony of our urbanized areas. Where we need the most water, we're contributing the least. Flooding. Sometimes we get too much water, and drought, sometimes we get too little. Once again, that's what when we talk about resiliency, that's what we're talking about, building resiliency into our communities to manage all of these challenges. So overconsumption of groundwater. This is a map showing the groundwater wells into the sand and gravel or the limestone in our area. Most of these in your area are between 100 or 750 feet deep, depending on which type of aquifer they're tapping into, whether it's sand and gravel, the limestone dolomite, or the sandstone. Zooming in on the DeKalb area, these are showing the different wells and then the depth of those wells. In McHenry County, we've got 30 to 40,000 private wells tapping into the sand and gravel or the limestone. So you would see a lot more blue dots if you were in McHenry County. But each of these wells is providing water to the community. And when we zoom in, when drillers drill their wells, they record the geology that they encounter as they go down. So we actually have a physical record of the geology that they encounter as they go down. And these are really important tools for us to understand where our water comes from, the threats to the water, and how to protect it. So this well is 1,300 feet deep, and go down, we're going down different geologic layers. One layer is they're going through the St. Peter in this well. and then going down to the Ironton-Galesville. So I think in DeKalb, most of our water, you can correct me if I'm wrong, but most of our water is coming from the Ironton-Galesville. And they're getting the water from that Ironton-Galesville from about 300 feet down of water that's providing that. And when we talk about our sand and gravel aquifers, it's not just a single layer of sand and gravel throughout the county. Some areas will have a lot of sand and gravel, some areas have nothing but clay, but what we see more often are different layers. And it is important to understand this. So this is what's referred to as an unconfined aquifer. So the sand and gravel is open to the air above it. There's no layer of clay on top of it. So unconfined aquifer, this is a layer of clay, that's a confining layer. The clay has very small particle sizes, so it restricts the flow of water. Then it's on top of a confined aquifer. So unconfined aquifer, confining layer, confined aquifer. One of the benefits of an unconfined aquifer is that it recharges very quickly. Every time it rains or snow melts, that water is able to infiltrate very quickly. But that also means that pollutants can get down into that aquifer very, very quickly. And so if you have a 40-foot well in an unconfined aquifer, that is very susceptible to contamination. If you are in a confined aquifer, that confining layer may protect your water from a water quality perspective because it's going to really limit the pollutants that can get down to that. But the same mechanism that's restricting the flow of pollutants also means that that water is going to move through there very, very slowly. So depending on the thickness of that confining layer is going to dictate how quickly your aquifer recharges. My last house was a farmhouse, and I had 150 feet of clay and a 5-foot seam. And that 5-foot seam of sand and gravel is where my water would come from. When I moved in, I tested the water and had very high fecal coliform bacteria counts. And so I had to shock the system. So you put chlorine bleach into your system, let it sit in your pipes, that kills the bacteria, but then you have to flush the system. So the water conservation guy for the county is having to waste water to flush the pipes. And I had to do this 3 times. It killed me. But every time I did it, my well ran dry because the recharge rate to that aquifer is so slow. It's having to move through that 150 feet of clay before it's recharging that aquifer. So it really was a stark learning lesson for me in my own house. And when we turn our pumps on, it's lowering the water table and creating what's called a cone of depression. So it's desaturating, it's pulling water from all around, but it's desaturating the land above it. So if you've got a 50-foot well and you've got a neighbor who comes in and puts a McMansion with 20 bathrooms and drills a well 100 feet deep, that cone of depression can be stealing your water. And this is what happens in the world around us. So once again, it's important for us to understand where our water comes from and the opportunities and constraints of those aquifers. Now, when we turn on our high-capacity wells for our municipalities, that can draw the water table down by 400 feet. And so that 400 feet drawdown is affecting the water table in that aquifer and creating a much deeper cone of depression. And I'll show an example of that later. So once again, looking back at this map, focusing on the St. Peter, like I said, in our area, we aren't able to use the St. Peter, but you guys are actually getting some recharge to the St. Peter that we don't really have access to. So this is where a lot of you may have heard of the Troy Bedrock Valley, these were like Grand Canyon in the area before the Illinois Ice Age. When the Illinois Ice Age came, it filled in these massive valleys with sand and gravel and glacial till, so you can't see that valley anymore, but it's still there. And that goes down to the St. Peter layer, so it provides a conduit for water to hit the land surface and make its way down to that St. Peter aquifer and provide some recharge. Our understanding of this is not that great at the moment. We've known about it a long time, but we're still learning a lot about that deep bedrock valley. So this is an illustration. There's a great publication. Made it a little bit too small, I apologize. But if you Google Troy Bedrock Valley, DeKalb County, you should be able to find this report. The walls of the valley were the limestone dolomite. So and then that went down to the St. Peter sandstone. And then this whole valley is filled in with glacial material. And these are a couple illustrations. There's actually a good model up here that you guys will have a chance to look at. And what this model is showing is the Troy Bedrock Valley. And so that's shown right here. So this is a deep valley cut through the earth, and it's going down through the, these are showing the walls of the limestone dolomite down to the St. Peter sandstone. So water is able to land on the surface and make its way down and provide recharge to that St. Peter. So once again, the unconfined and confining layers are affecting the ability for water to make its way from the surface down. And so we need to get a much better understanding of the material in there. And, but the same mechanism that allows for water to infiltrate down also means that pollutants can infiltrate down. And I know in Boone County, their industrial corridor goes right over the Troy Bedrock Valley. And there's no way to undo it, but what you can do is have requirements for best management practices to reduce the risk to the aquifer when new development is coming in. It's fascinating. You guys are in a very unique geological area, and you know, when I do presentations outside of my own territory, it's always fascinating to learn more and more about geology. My background is actually ecology, and so I joke about now that I'm having to learn to be a geologist and taking geologic time, I'm using brain muscles that have either atrophied or never been used. So it's really, when you start thinking in geologic time, it really gets hard to use those muscles. Fascinating though. And another unique thing about your area, so major confining layer is this layer called Kuykendall shale. So that is a layer that just does not let water through, and that is a restrictive layer. Another reason why we're not able to get local recharge into the sandstone layer to the east of us. But in your area, you're right at the end of Kuykendall shale. And so once again, that's allowing recharge to get down to that St. Peter sandstone. Now, I'm still not sure that the connection between the St. Peter and that Ironton Galesville that's in our area, the wells are about 1,500 feet deep. So I still think the recharge to the Ironton Galesville is fairly limited, but you guys are in a very unique geological area that's pretty fascinating. Yep, once again, our superhero side view here. So the Ironton Galesville underlies 7 states. Once again, it formed when we had inland seas and North America was at the equator. So this is where we are, and McHenry County is right here. The water we're getting through in this entire region is largely coming from Wisconsin, where that Ironton Galesville rises up towards the surface. So when it rains or snow melts, water is actually able to get into the Ironton Galesville sandstone, and then it slowly makes its way towards us. But the pore spaces in the sandstone are tiny. It does not allow for rapid movement of water. So basically, as soon as we're pulling a drop of water out, the water table is dropping. The recharge rate to that aquifer is slow. It takes 1,000 or thousands of years for water to land up in Wisconsin, get into that aquifer, and slowly make its way towards us. So that is a non-renewable aquifer for the most part. Once again, you guys are in a little bit more unique area, but it is a non-renewable aquifer. So throughout the entire Chicago region, that is the main aquifer source for many of our municipalities. And the Joliet area has dropped that water table down by about 900 to 1,000 feet. So that 1,000-foot drawdown, it creates a cone of depression that extends outward. So that cone of depression is radiating outward underneath McHenry County in the southeast corner of the county, where we have the greatest population density. The water table is dropped to about 400 feet. And as I mentioned before, when we turn our high capacity wells on, that drops the water table down another 400 feet. So the water table is now at or underneath the actual bedrock. That at that point we start having risk of well inoperability, and we're running the risk of running out of water in parts of our area. But it is kind of interesting. So you see the gradual and extreme drawdown extending to the north, but look how rapid and steep that slope is here. So that indicates that there is some recharge occurring in our area. But in all honesty, these maps are based on limited information and outdated information. So the mapping that the water survey provided us in 2020 did not account for about 20 new wells that went in our area. And so the risks that we are running into are even greater than what the projections are. So this is McHenry County, the southeast corner of the county. And so 2020, this brown area is representing areas at risk of declining well performance. Forecasting out to 2020, this risk of declining well performance extends out throughout many counties. King County is actually in worse shape than we are in many ways, and then it is extending out towards DeKalb County. And this is data that's based on very limited information and information that was before many wells went in. So I expect this to be much broader if we were to rerun the analysis now. And then we are seeing areas of hotspots that are at risk of well inoperability. So these are questions that we are looking into. You've got municipalities looking at the feasibility of getting Lake Michigan water. Joliet, it has less than 10 years worth of water left. So they are getting ready to spend $1 billion to run a pipeline to buy Lake Michigan water from the city of Chicago. That means for all eternity, for Joliet to exist as a city, they are going to be dependent on the benevolence of Chicago, basically. Now, they're going to be paying for the water. Water rates are going to triple overnight. It is expensive water. If we have access to safe, sustainable supplies that are recharged locally, we'll be in much better shape into the future. When I think about water resources, I'm not thinking 20 years from now. I'm thinking 50, 100 years from now. And so these are very real issues. Like I said, the issues that the rest of the country, the rest of the world are facing are the same challenges we will be facing. The demands we have on our water today are not the demands that we're going to face tomorrow. New industries can come in and completely turn demand on its head. But you can actually have increased population density, increased economic development, and decreased demand. But that only happens through intentionally making changes. Water conservation is part of our future, and water conservation provides greater economic opportunity. Water conservation and protection is our economic strength, plain and simple. So loss of groundwater recharge, as I mentioned before, every area of paved surface that we're putting it down means that water is not infiltrating down. As we compact the soil, that's reducing the ability for water to go down. Drain tiles are altering the hydrology. Now that's largely moving seasonal groundwater, but we really don't understand what the overall impacts are on from all of our drain tiles on our groundwater recharge either. No matter what, these are all very altered hydrologic cycles, and it's something we need to get a better understanding of. Water pollution. When we talk about water pollution, typically two main things that we're thinking of. So point sources are pollutants coming from an industry, a single point. With the Clean Water Act, we've really done a great job. I'm old enough to remember how we used to dump raw sewage and toxic material into our waterways. We've done a much better job with that. But today, non-point sources or stormwater are the leading cause of water pollution to America's waterways. And we are getting better understanding of how to protect our stormwater. But our stormwater is our groundwater. So if we're polluting our stormwater, we are polluting our groundwater. Once again, it's basic mechanics. And kind of the way this works in an urban area, at least, is I don't think we have combined sewers in DeKalb, do we? Anybody know? I don't think so. So in a sanitary sewer, that's taking the wastewater from our houses and businesses, putting it into a dedicated sanitary sewer that then goes to a wastewater treatment plant. That wastewater treatment plant cleans that water before it discharges into our nation's waterways. So all of this water is treated. With our stormwater, the water is collected, runs overland, it's collected into storm drains and catch basins. That is discharged directly into waters of the United States untreated. There is no treatment that occurs. So the only way we're going to protect our nation's water quality is preventing pollutants from getting into that water in the first place. And we really don't do a very good job of this. We need to do a much better job. In a presentation I gave last year, I had a confession. When I was 18, I bought my first car, and my buddy, who was a mechanic, taught me to change my oil by pulling the car up so 2 tires are on the road, 2 tires are on the sidewalk, and your oil pan is over the storm sewer. And I remember asking him, "Are you sure we should do this?" He's like, "Oh yeah, it gets treated before it goes out to the lake." And so, okay, undo the plug, drain all that oil into the storm sewer, only for that to go directly into the lake. I've lived with that guilt for 40 years. And before the presentation, I went back to my old neighborhood to take a photo of the storm sewer so I could include that in my presentation. They had just changed the storm sewer out so that it actually had a nice wavy thing to look like water, and had an emblem on it saying, "Do not dump, discharges directly to waterways." So if they had done that 40 years ago, that would have saved me 40 years of guilt and heartache. So nobody's perfect, but as we know better, we need to change our behavior. And there are a lot of things that we can do to do that. So examples of common sources of non-point source pollution, one of the biggies is salt. We use far more salt than is necessary. My presentation this morning was a sensible salting program. McHenry County, we are true leaders when it comes to sensible salting. Basically, when we talk about sensible salting, we're talking about maintaining safety on roads, but we're only putting down what is necessary to maintain that safety. Anything beyond that is waste, and it comes at great economic and environmental cost while providing no benefit to humanity. So that's what we want to eliminate, is that waste. And there are a lot of tools in the toolbox. One of the main things that we use are liquids. We put liquid brine down on the pavement before a storm, and that prevents ice from bonding to the pavement, which makes it easier to physically remove that snow, get back down to safe pavement without repeated applications of chemicals. We don't want to be using chemicals to just burn off snow and ice. Our road salt are toxic chemicals, and we need to get much better at how we use it. Certainly, pesticides, fertilizers on homes and farmlands can be part of the problem. Fly dumping. This is not me, but that is commonly done. Accidents, if it's not cleaned up properly, leaking underground storage tanks, fuel containers, all of these things are major contributors to water pollution in our area. And all of these have solutions. We don't need to keep doing the same thing. And when we talk about pollutants, different pollutants react differently in our water. So when I first started working with engineering firms 30 years ago, dry cleaners were one of the big things we were trying to clean up. So the solvents that they used were called PERC, and it's commonly referred to as a sinker. So once it gets into the soil, it moves through the soil, gets into the groundwater table, and then sinks down to the bedrock, and it stays put. So it was actually relatively easy to clean. We would drill wells down and pump the material out and aerate it to clean it from the water. Petroleum, that'll get down, soak through the soil, get to the water table. Oil and water don't mix. So it kind of stays at the surface area, but all of these are carried in the direction of flow. So it creates a plume. And then any type of solvents or anything that actually dissolves into that water, including chlorides, become part of that water column. And that's particularly problematic. And that can travel long distances. I think some of the hazardous material that's in that Marengo area has traveled miles. So everybody down gradient has had to go on to bottled water, get rid of their cattle or their horses. Otherwise, they'd be watering their horses with polluted water. I mean, this is happening all around us. This is not just theoretical. This is happening. This is just an illustration of a plume. So you'll typically have a higher concentration closest to the source of the contamination, and it'll dilute as it goes on. But depending on the nature of the pollutant, that can travel very, very long distances. Flooding, like I said, sometimes we get too much water. This is a diagram showing the precipitation patterns from the 1800s on, and there's just been a steady incline. Year to year, you're going to have quite a bit of variation. But this is math. I mean, this is what we have to use to calculate our storm events. We've had to change the actual numbers that we use to calculate storm events. This is real. This is happening. And the water that our cities are designed for are not the amount of water that we're getting today or what we're going to get tomorrow. So how are we going to adapt our built environment? We're going to have to figure this out. These are all images from McHenry County. So once again, this is the real world that we're having to contend with. Drought, sometimes we don't get enough water. One of the ironies is that when we get in a period of drought, we're contributing less and less to the water table, but pulling more and more water out. Just think of our water table as a bank account. We're just exhausting our bank account during periods of drought. This is the U.S. Drought Monitor, and so this is from October 30th for Illinois. You can see different stages of drought throughout the state. So right now we're not too bad a shape. Moderate drought, abnormally dry. But did I get rid of those things? Oh, I had other slides showing past droughts. So 2012 was a catastrophic drought, but that was just part of 1 year. In McHenry County, we had about 3+ years of drought. And it was this weird cloud of drought that just wouldn't go away. All around us recovered, but this weird cloud of drought persisted. So I'm part of a group with NOAA and other organizations, and so I showed them the maps showing our drought and this weird persistent drought, and asked them if there's like a technical name for this type of drought, or if there's an explanation for it. And they said, "Oh yeah, it's called bad luck." But one of the things that is happening, and I did mean to include a slide on this, is we are experiencing different types of drought today. So one of the things that is being observed throughout the Midwest is flash droughts is what it's referred to. And so the atmospheric conditions are set to just suck the moisture out of the ground. It's not something that we really had a lot of history with, but these are very real conditions that are having to be contended with. I think it's much more prevalent downstate, but these are very real issues. So drought is a major, major issue, and we're going to have to figure out better and better ways to deal with it. So in McHenry County, we have done a lot to understand our water. So I'll quickly go through some of the things that we've done that others are replicating. So first off, in the early 2000s, we were experiencing exponential growth. The growth rate was just going nuts. And our county board wisely asked, do we have enough water to support the projected growth? And so we did our first major study, and we looked at both our sources of water and future demands. And it was clear that we had challenges. Our water sources are finite, and they're vulnerable to pollution. Was the main finding of the report. That was very sobering. But while this looked at the problems, the county board said, well, what about the solutions? So then we developed a water resources action plan to look at the different challenges and what are the best management practices that can be implemented to manage those challenges. One of the things that came out of that is we worked with the U.S. Geological Survey to install a network of monitoring wells throughout the county. So I have 37 monitoring wells distributed around the county. This is what they look like. Every 15 minutes, it's taking a water level measurement, transmitting that data up to the U.S. Geological Survey satellites, then they maintain it for us. And your DeKalb field office is the one that manages this for us. And they did an amazing job working with us to create a user-friendly mapping program. So anybody can go on here and pull up, it shows a map of McHenry County. It shows where all of our wells are. They're color coordinated to show whether water levels are normal, low, or high. So within a second of pulling up this map, you can have a solid understanding of what's going on in the county from a drought perspective. And we've been collecting data since 2009. And this is really important because we've been able to capture multiple periods of drought and periods of record rainfall. If we were to collect a sample here, here, and here, that really wouldn't tell us much. Having continuous real-time data collection over a long period of time helps us understand how the different aquifers react to changing precipitation patterns and changing demand. And because the different aquifers or different wells are going into different aquifers throughout the county, confined, unconfined, confined, and deep aquifers. So where these show gray with numbers, those are what we call nested wells, where we'll have a well going down into the shallow aquifer, the intermediate, and the deep, or the shallow and the deep. And so once again, we can have a much better understanding of how the different aquifers work in the different parts of the county. And so I'll just go through a few of the graphs. This is a fairly common pattern. And so you had 2012, which once again was a catastrophic drought. It really impacted agriculture hard, but it was just a seasonal drought. It was part of 1 year. That was followed by record rainfall. And this is an important distinction too. We can have periods of drawdown, and as long as we're not pulling water out faster than it's naturally being recharged, our aquifers can recover. In many parts of the country, many parts of the world, when they draw the water table down, the land subsides. And the pore spaces that will allow for infiltration to occur or to store water are gone forever. The fact that ours are resilient enough to have periods of drawdown and recovery, once again, you cannot come up with a better storage device than what we have naturally. This is a well that recovers very quickly. So it's actually a fairly deep well, 150 feet deep. This probably has some confinement, at least, maybe a thinner layer, but it recovers pretty quickly to drought and rainfall. This is another opposite end of the spectrum. This is actually underneath about 70 feet of clay. And kind of interesting is all the other wells in the county were going into drought and going from blue to red. This stayed green long into our drought. But then when it went red, it just stayed red. The reason it took so long is because that 70 plus feet of clay holds onto that water tightly. So it took a long time for that clay to desaturate. But now that it's desaturated, it is very tough for that aquifer to recover. We have a well, a subdivision nearby this well. The homeowner had built his dream house and in less than a year ran out of water. He could only do laundry every 2 weeks and was really in a panic. And this clearly spells out why he was having that trouble. In his case, the well still had 12 feet of depth to it, so they were able to lower the pump down and he was able to get water again. But his was the 8th house to go into a subdivision platted for 80 houses. What's going to happen when those other houses are built? Once again, these are real issues that are happening here. This is not out west. This is right here. And so as a county, we do not want to encourage rural subdivisions. And this is a really striking reason why that is important. So just look at the thinness of this. All the lines that we've looked at, then look at the thickness of this. It's really interesting once you start learning how to read the patterns, the signatures. So this is a signature of pumping. It's right near a well for a municipality. So every day they're turning their pumps on and off. And so that creates this higher fluctuation of rising and falling. So it really is pretty interesting. This is one that we're really working to get a handle on. So we had our drawdown in 2012 and then recovery. 2020, we started getting this very distinct signature. So what happens is it drops down in the spring, recovers in the fall. Drops down in the spring, recovers in the fall. So this is a signature associated with irrigation pumping. So well, we have a golf course near one of our wells where the water table drops 30 feet every spring, recovers 30 feet every fall. And this has been since 2009. It's had this steady pattern. What's happening here, though, is the drawdown and recovery every year are getting lower and lower and lower. This is unsustainable. So we have another resource that I'll talk about next that shows where our aquifers are. And so we're able to show that this aquifer is right next to a new subdivision that's being built. So the houses started being built in 2020, along with all the landscaping going in, all the new yards, all the new landscaping throughout the subdivision. It's a subdivision platted for 4,500 new homes. And this started with the first 70 new homes. So what's going to happen as that builds out? So the municipality has actually accelerated their timeline to install 2 new deep bedrock aquifer wells going down into the Ironton Galesville, which is a non-renewable aquifer that we are facing shortages in as soon as 2050. So once again, these are real issues happening here. But we wouldn't know about this if we didn't have these resources. We would not know about this until wells went dry, and then we'd be forced to react and try and figure out what was going on. In this case, we're able to work with all the stakeholders and intelligently address the issue. This, I think, drives the point home of why data collection is so important. We also use these wells for drinking water. So every 10 years, we're going out at each of these wells, collecting water samples and running a full battery of water quality analysis so that we can see trends over time. If we start seeing trends, we can change behavior. If we're not doing this, it won't be until people get sick that we would be able to make changes. In 2020, I did get a little additional funding to collect samples for PFAS, and we also got samples for microplastics. So PFAS, often referred to as forever chemicals, and sadly, we did find PFAS in many of our wells. So we consider this an exploratory analysis, so we need to go back and do a more intentional analysis now. But once again, these are real issues happening here, not theoretical happening elsewhere. One of the great things we did is we worked with the State Geological Survey to do 3-dimensional mapping of our subsurface geology. We're not superheroes, so we can't look through the earth and see what's going on. We can't look at the land surface and know what's going on underground. So this is a technology that's really moving across the country, or around the world now, where we actually do 3-dimensional mapping of our subsurface geology. And you can go onto our website and run a transect line, and it shows a profile view. The lighter colors, the yellows, golds, and browns, are the areas dominated by sand and gravel. So those are the aquifers or the recharge to those aquifers. So unconfined aquifer, confined aquifer, and on our interactive website, you can go anywhere in the county and run a transect line over your area of interest, and then it pulls up a profile view of the geology underneath that transect line. And so typically what I'll do is I'll run a transect line from east to west, and that'll provide a profile view north to south and then diagonally. So you are quite literally getting a 3-dimensional perspective of the geology in your area. We can use this for planning. My next meeting is the Emergency Management Agency. So if we have a spill here where it has to go through hundreds of feet of sand or of clay, we can allocate resources to other things. If it happens here where we have 100 wells in unconfined aquifer where contaminants can get in very quickly, we can allocate resources intelligently differently. So having this information is incredibly, incredibly important to manage our water resources into the future. This is just a bigger view. So once again, looking at the different types of aquifers and where you have confining layers, it's just fascinating to look at. I have learned more about the geology of our county through this resource alone than any other resource that I have available. And then we utilize mapping information to create what we call a sensitive aquifer recharge area map. So these are the extremely permeable soils or highly permeable soils in the county that provide a direct conduit from the surface to the aquifers. So these are our most areas that get the most recharge to recharge our aquifers. They're also the most sensitive to contamination. So we can use this map for both planning. So we actually, in the unincorporated areas, if you have a property that has MAP-SARA on it, 50% of that MAP-SARA area has to remain permeable. So we are using this to protect our groundwater recharge. And then ideally, if you've got a chemical recycling facility being proposed, it should be outside of the SARA area as opposed in the SARA area. So you really can utilize this effectively for very quick analysis. I mentioned sensible salting before, so I won't go too deep into it, but we're talking about maintaining safety while eliminating the unnecessary application. We want to get rid of the waste. And so we've been hosting sensible salting workshops since 2009 and have trained thousands of people in sensible salting practices. And like I said, there are a lot of tools in the toolbox. The main thing is cover and contain. If you have an open pile, every time it rains or snow melts, that is just pouring chlorides into our waterways. There's just no excuse for it in this day and age. Calibrating equipment. Equipment does not come from the factory calibrated, nor does it stay calibrated. So at least once a year, you need to be calibrating your equipment. I often refer to this as like going into combat without sighting your weapon. You're going to hit everything except what you're aiming for, and you're going to run out of ammo very quickly. Boone County brought their vehicles to us. Great folks over there. Justin wanted to take advantage of a program where we would train people to calibrate their equipment. So they thought they were putting, the unit of measurement is pounds per lane mile. So they thought they were putting down 300 pounds per lane mile. When we calibrated it, 900 pounds per lane mile is what they were putting down. So they're throwing away all that salt, and then that's contaminating our waterways. The salt actually destroys the concrete, destroys our infrastructure. So the economic damage, the environmental damage, and they didn't even think they were doing it. So once again, it's important to do this. And then anti-icing, like I said, we put liquid brine down. We're putting a fraction of the amount of salt down while actually having safer roads using these practices. So this is very real opportunities out there, and we're happy to collaborate. Anybody that works for municipalities or the county that would like to partner with us, we'd be happy to work with you. And then 2020, we updated that Water Resources Action Plan, where we are looking on what are the solutions to protecting our water. And then Boone County has tried working with us to replicate some of the things that we've done. So they had created a sensitive aquifer recharge areas map. And then this past year, they did three-dimensional mapping. Is anybody familiar with what they did over there? So it took us 3 years of data gathering to create our program. They were able to do this in a week. Let's see, is there a way? So helicopter carries this ring. The ring is basically like an MRI, so it's able to capture images up to 1,000 feet, depending on the type of material. They did their survey, running their transects, the grids, in a week, where it took us 3 years to do the data gathering. Technology has evolved so much, and the resolution that they're going to be able to get with their technology is going to be even better than what we have. So what we really want is this to be done statewide, but these are things that are happening in our backyard. Kane County is replicating our monitoring well network, and then we draw things from Lake County next to us. So we are all working very collaboratively. So once again, if there's anything we can do to be of service, we're happy to help. So water is necessary for all life. Because it's necessary for life, water is necessary for economic development. It is our #1 economic driver. And our water resources deserve to be protected and conserved. Our water conservation is our future. That is our economic strength. And so it's important for us to understand how we can help protect our water resources now and into the future. So here is my contact information. If people want to take a photo of that, you can feel free to contact me. I have time for maybe 1 or 2 questions, and then I do have to drive an hour and a half in an hour. Yes?
So, real quick, just clarifying, we don't have these things in our county. We don't have the geological map. We don't have monitoring wells.
Not that I'm aware of, no.
I just want to.
So, yeah. Yeah, and once again, that's why it's important. And the information that we have is pretty limited in DeKalb County. He must have gone back to the office, but you guys are part of what we refer to as the Northwest Water Planning Alliance. So it's a water planning group that focuses on protecting groundwater resources. I should say non-Lake Michigan resources. And so you guys are part of a very important group. I think you had your hand up. Well, so one of the things that we do, we have a series of what we call talk and tour workshops where we showcase best management practices that have been implemented in or around McHenry. Our second to last one was in Huntley, where they are reusing water for irrigation. Water reuse, when we're looking for new sources of water, so that's wastewater. And so water reuse, whether it's gray water or wastewater, that's part of our future. But right now, state laws really make it very difficult to do. I spent some time in New Mexico, and they're actually using treated wastewater to recharge their aquifers. A week or two, I'm going to a conference with the State Water Survey in Will County, I think, where they refer to it as managed aquifer recharge. So this is going to be part of our future. But we've got a long way to go. But like I said, in New Mexico, all the new subdivisions have to have their own wastewater treatment plant. And then it's purple pipe throughout the subdivision, and that's the only water that can be used for irrigation. And they have to use native plants. They can't use anything else for landscaping. I think you actually had your hand up next, and that'll probably be my last question. I'm sorry, who did? Oh, okay. Yeah, I don't. Well, and then there are also land application systems. I don't know if that was what that was, or if it was. So what they do is they'll treat water to secondary drinking water standards, and then spray it on the ground, and then that tertiary treatment is actually, as it infiltrates down, I guess it's somewhat similar to a septic system from a treatment level. But those can be complicated systems. We actually had a challenge in McHenry where a subdivision didn't get fully built out, and they took all kinds of shortcuts without letting anybody know, and it actually became a big problem. So it may be a similar type of situation. But once again, I'm just so impressed that you guys are here. This is incredibly important information, and to be honest, it is cool information. I mean, it's just fascinating. But this is part of life. I mean, this is how the world works. And so you guys are, ahead of the game when it comes to understanding how the world works and our role in it and how we can actually have living areas long into the future. So I just commend you for being here. But you got my contact information, so feel free to reach out and keep doing the great work. And you've got a lot of great things that you'll be learning today. So thank you for putting this together. Thanks, guys. Yep.